Hello, my lovelies. It's Susanne, and today I want to show you how to solve this problem. A large square is divided into 4 smaller squares. We have our large square here, and inside we have these 4 smaller squares. A circle inside the square touches the midpoint of the right side of the large square. So inside here we have this circle and it touches this right side here in the midpoint of this side. What is the side length of the large square? So we have to find this length here. We are also given the length of this part here and the length of this part here. And this is all the information we have to find our x. Okay, how can we find x then? Because it is a square, we first know that this side down here is also of length x. Then, because the circle touches my side here in the midpoint of this side, I know that this here is half of the entire side. So x is the entire side, half of it would be x over 2. Okay, let's go to the circle. We can draw the radius of our circle from the center to the edge of the circle. So this is my radius. But usually these touching points here, and we have another one here and here, are really important if you want to solve such problems. So I wouldn't draw the radius here, but I would choose these touching points. So from the center to this touching point here, this is my radius. Also from this touching point to my center, this is my radius, and here as well. And now we've created a triangle. Can you see it here? This is even a right triangle because this here is my square, the small square, so I know I have a right angle here. And what do we know about the side lengths of this triangle? We know that this is of length r. What about this side here? If I want to find this length, then the entire side here, this is my x over 2. I'm not interested in the entire side, but I also know the length of this part here that I'm not interested in. So I would just subtract the 6 from the entire side to get just this part that I want to know. So I take the entire side, the x over 2, and subtract this part up here, the 6, and then I know this is this length here. What about this part down here? This is not my r, because r was the entire radius, this here. So if I just want to know what this part here is, how can I do that? Well, I also know the length of this entire side here again. Why? Because this is the side of my small square, which is of length x over 2 again. I'm not interested in the entire side, so I would have to subtract the part that I'm not interested in, which is my r. So let's do this. We take the entire side, the x over 2, and subtract this part here, the r, and then this is what is left. Okay, now we can use the Pythagorean Theorem in this right triangle. For this, we first have to find the hypotenuse. That is always the side that lies across the right angle, so this is the hypotenuse. And the Pythagorean Theorem then says, take one of your sides, so we take this beautiful expression of our side and square this entire thing, plus take the other side and square it. So we also take this next beautiful expression and square this entire thing. And then you get the hypotenuse squared, so r squared. So now we have one equation. The problem just is that we have r and x as unknowns in here. So it would be great if we could find a second equation with r and x so that we could solve this system of equations then. What do we know about r and x and their relationship? We have r here. Here we have another r, and then we have the 8. So we can go from the left here to the right using 8, r, and r. But this is also the length of this square here, which is of length x. So now we found a relationship between x and r because x is equal to 8 plus r, so plus 2r. And now we have two equations. We take this system of equations now and try to solve it. One way would be to use this x here, because this equation is already solved for x, and insert it for x here and for x here in the first equation. This is going to be a big expression here, but let's do it. We start here with our first parentheses. So we have, instead of the x, we're going to write down 8 plus 2r. Then we divide it by 2. We subtract the 6 and square this entire thing. Then the plus. Next, the same thing with the x here. We replace it by 8 plus 2r divided by 2. This time we subtract the r, but we also square it, and then on the other side we have r squared. And now we only have one equation and one variable in here. We can solve this equation for r now. Of course, we have to simplify it a little bit. It's a little bit of work, but it is possible. So let's start here. We have this big fraction with a plus here, so we could write this one fraction as two separate fractions that are added, so that we have 8 over 2 here first, and then the second part, the 2r over 2 here. We subtract the 6 and square this thing. Then we could do the same here again. Because of the plus, we can write it as two separate fractions. 8 over 2 first, 2r over 2 then. We subtract the r, square this entire thing, and on the other side we still have the r squared. Now, 8 over 2 equals 4. Then here we can cancel out the 2 and only r is left. So we only have r here. So in total, maybe we start with the r first, so that we have r, and then 4 minus 6 equals negative 2. And then we square this, plus. In here, the same thing, 8 over 2 equals 4. Here we can cancel out the 2, so only r is left here as well. R minus r vanishes completely, so that we only have 4 squared, which is 16. And on the other side, we have the r squared. Okay, this looks good now. Maybe we get rid of these parentheses now. We have a difference in here, and all of this is squared, so this is a special product. And we can use a formula to get rid of these parentheses, because every time you have something like a minus b and square this thing, then the result is a squared minus 2ab plus b squared. So let's apply this formula here now. We take the first thing and square it. So r squared minus 2ab. So 2 times r times 2 equals 4r plus the second part squared. So 2 squared equals 4. Then we have the 16 here, and the r squared is still on the other side. Okay, now we have 4 plus 16 here, which equals 20 already. Then we have r squared here, r squared here. If we subtract r squared on both sides of the equation, this cancels out. We have negative 4r plus 20 here. Here, this cancels out, and we get 0. No r squared here anymore, which is great, because now we can solve for r by subtracting the 20 here first on both sides of the equation, so that we have negative 4r. This cancels out. On the other side, we have negative 20, and to solve for r, let's get rid of the negative 4 here by dividing both sides of the equation by negative 4 here and here. This cancels out, only r is left, and negative 20 over negative 4 equals 5. We found our radius. Were we interested in our radius? Not really. We wanted to find x. But let's take our radius. Let's go back to our system of equations, because now we can find our x by inserting our radius here in this equation. So we get x finally as 8 plus 2 times my radius is 5. So in total, my x is 2 times 5 is 10 plus 8. So it's 18, and we've solved our problem. If you liked my video, please give it a thumbs up. It helps me a lot. I wish you a wonderful day, and I hope to see you in one of my next videos. Take care!